I'm the one who knocks.
Is that the lasting lesson from 224? And was it on your 2 pages of notes for the final? All right. So let me preempt some questions and talk about this business of drawing in the tic-tac-toe board, because this is a little different from how we kind of think about doing things in a program procedurally. So let's think about the paint method in your J panel or whatever it is that you're drawing on. It needs to do the following. It needs to draw a tic-tac-toe board, which means probably making 4 calls to draw a line, or maybe fill rect if you want thick lines and you're going to actually make filled rectangles. But somehow you got to draw 2 lines up and down and 2 lines across. Okay? And then you want to draw X's and O's and maybe draw a line through some winners. So you need some data somewhere, right? You need somehow to know when a user has gone in a particular square, and you need to know what their mark is. And so you could do something like this. You could have a 3x3 array of characters. I'm just calling it board. And the understanding might be if it's empty, right, then it's empty. If it's an X, then it's an X. If it's an O, it's an O. But it's just a way to store information, right? So when you begin playing, what you do is you go through and you zero out this board. You set every element in this array to a space, right? And that indicates that there's nobody who's moved there. Okay, now the user comes in and they move first, and so they click right here. And so you might do something like board 0, 0 equals, let's suppose the user is X. And the CPU is O. So you click and you get XY coordinates of the mouse, and you do your decoding to figure out what the row and column is, and let's call that RC. And so board bracket R bracket C would be equal to whatever the user's mark is, okay, such as X. And then the CPU decides where to move, and it comes up with some row and column where it wants to make a mark. And so again, you say board bracket row bracket column, but in this case you set it equal to quote O, or to whatever the CPU's mark is, right? So if these are just characters, I can just copy that over. But somehow you populate this board array with symbols, with information that says who's in each square. And the trick is, every time that you do this, you call repaint. So what does paint do? It goes through and it calls the superclass paint, which erases everything on the panel. It calls for draw lines to draw the playing field. And then you want to do something like go through a pair of nested for loops. For row goes from 0 to 2, for column goes from 0 to 2. And I'm just being modular here. I'm calling a method I call doMark. I pass it the row, the column, and the symbol that I want to put in that row and column. Right? Now, if nobody has moved in this particular row and column, I'm going to pass this with an argument that's a space, and my doMark shouldn't do anything. If the person whose X has gone in this row and column, I'm going to pass this with a third argument of X, and my doMark should draw an X in that row and column. And if it's an O, I should draw an O. So you do the inverse of your coordinate mapping. If this is row 1, column 2, I need to know I'm coming down 1 going over 2, figure out the coordinates of this box, and if I'm drawing an X, draw 2 lines. If I'm drawing an O, draw a circle. And do that across every row and every column. So what happens when a user clicks on a square? You don't actually do any painting at that point. You don't, inside your mouse handler, say draw a circle or draw an X. All you do is update this data field. Just update the board array or whatever it is you're using to record marks, and then call repaint. And repaint is always going to draw the field, and then it's going to go through this array and it's going to draw up to 9 marks, right, depending on what this field is set to. And when the CPU makes its move, it does exactly the same thing. It just updates some field inside this array and it calls repaint. And it's paint that's actually doing the marking here, right? But that's a separate piece of code from the one that's actually deciding what the XY is that the user clicked in, or where the CPU is going to move, right? So these are separated out. And if there's a winner, this paint method also needs to draw that line through the winning marks. And how do you do that? Well, you can go through all the possibilities for where somebody might win, and you can figure out the beginning and ending parts, and you can draw that line. But here's a different suggestion. Inside here, when the user clicks on a square, or when the CPU makes a move, call a check win method. Because it's going to be the same thing whether you're responding to the user move or the computer's move. You need to basically go through and check every row, check every column, check the 2 diagonals, and see if they represent the same mark.
Does it automatically draw it over everything else?
If you draw the line last, it will include whatever was already drawn.
Okay.
Yeah. So make yourself a method that does that check and set up some more data. Have a Boolean flag, call it winner or something, that says has somebody won. And you could have 4 variables for where the x and y coordinates are of that winning line. So winning x1 and winning y1 are the starting point of the line, winning x2, winning y2 are the ending point of that line. And in your check win method, you check each of these possibilities to see if somebody won. And if somebody has won and nobody had already won, set the flag to true, populate these 4 values for the coordinates of the beginning and the end of that line. Now your paint method is still really easy. At the end of this, if there's a winner, then just draw a line between win x1, win y1, and win x2, win y2. It's 1 line of code. And it feeds into the idea that your paint routine should not be heavy, right? You can be called into this paint routine at any point in time, because we're only saying repaint, I want you to call when possible. You don't want to spend a lot of time inside paint. So do the harder work outside, set up some variables, and paint just looks at those variables and populates the window accordingly. Does that make sense? What you definitely do not want to do is inside here do something like, okay, the user just moved, I'm going to figure out where I want to move now, and run your AI and come up with the next square, and then draw it, and then update some data structures, and then check for winners and all this other stuff, right? Those things don't belong in paint. Paint is really about painting. So any heavy lifting you gotta do it outside, and Paint just looks at the data, does some drawing.
Can we have like 9 separate like J files for those?
You can do that. Seems like a lot of people are going that way. I think it's harder that way, but it'll be interesting to see. The advantage of doing that is that if you want to draw an X, it's always relative to that J panel, right? You can just hardwire the starting and ending coordinates.
Yeah, that's what I was thinking.
And when you click, you know that you're going to get an event for that J panel. But now you need to have 9 event handlers, and you can make a 2-dimensional array of J panels if you want, and then just pick up the coordinates maybe. So it'll be interesting to see which one ends up being easier.
Do you know if Paint draws, when you call draw a line, does it draw a 1 pixel line automatically, or is it like that? It does seem like some description of Paint was like it draws the line in the infinitesimally small space between pixels or something like that, so it doesn't technically take up a pixel when it draws the line. So your coordinates
Default
wouldn't
should be a
like,
pixel as far as I know, unless they're talking about like anti-aliasing or something.
Okay, so like whenever you're referring to it, it's always like +1 or -1 in terms of position.
Yeah.
Okay.
Yeah, I don't know what that might have been.
What was the straight line? You just
I might have just been getting too deep into something.
That's possible. Yeah, that can happen.
Especially in Flash.
Well,
All right, so be thinking about this separation here, right? And this makes it relatively easy to handle things like you know, if the last move is here and now there's actually 2 winning lines here. Well, traditionally you only draw 1 winning line, unless you really want to like gloat, you know, beat you twice. But if you do this, right, if you have your check win code, right, and it's going to set up the starting and ending coordinates for the winning line, right, there's only 1 winning line. And if the flag is set, your Paint method will draw it, and if the flag's not set, it won't draw it. Right, so it kind of takes care of that for you. But it logically separating these functions will simplify some of the stuff at the end of this, where you're dealing with edge cases and such.
So if you were to do it with the J panels in front of the other J panel,
Mm-hmm.
can you have the back J panel draw in front of the foreground J panels?
Well, yes and no. So if you call the super paint for that back J panel, it's going to wipe out everything you've drawn on those front J panels. And if you don't call the super paint method for that back J panel, I don't think your results are predictable. But do you need a back J panel?
Oh, well, the back J panel had all my buttons. And
Oh, so you got a big one.
start button. Yeah, I got a big J panel for
Oh,
all the
okay.
other stuff, and then
That's fine. I would say you don't have to do anything with that.
oh yeah.
Yeah. And when you lay this thing out in Swing Designer, right, you can set the Z ordering on your components, and you can say those little panels are in front of the big one in the back. And now when you do something like resize the whole J-frame, it should call repaint on that back panel first, and then call repaint on the little panels in front. And you shouldn't have to do anything with the paint method on that big panel.
I was just trying to think of if it would be easier if I could get the back J panel to put my winning lines,
Mm-hmm.
because it'd only be, again, it'd be hardwiring only 1 set of coordinates.
That's going to be tricky. Yeah.
But yeah,
It's
this is
gonna
the
be
part where I
tricky.
think I thought it was easier the whole way until that part.
Well, the winning lines aren't too hard with separate panels.
I figured if
It
it's
does take some
easy-
setting up,
Yeah,
but
I don't think it'd be too hard because you could just have it be straight lines and then
yeah.
You just go 0 to Y, or 0, 0 Y to maximum Y on each panel, but keep the X the same for each.
Right. Or
I guess that's only if you're going straight down.
you could have a switch statement
Trees.
that.
get back. All you really need to know is, does a winning line include this square, right? And should it be horizontal, vertical,
Exactly.
that diagonal, or that diagonal? And you can code that with a couple of flags.
Yeah.
right? And then in your paint method, just, it doesn't even know it's making a continuous line, it's just,
Mhm.
yeah. So that's probably pretty doable. All right, so other questions on PA3?
Do we get extra credit if you can't beat the computer?
If you can't beat it, yeah, you can make it so it's not beatable.
I've
You
tried
get-
my hardest.
You get fame and glory.
Okay, that's what I'm going for.
Okay, you definitely get that. And if it spawns into Skynet, then you know who to look to. That'd be horrible if it started with a tic-tac-toe game.
Only winning move is not the
What?
The only winning move is not
Yeah, exactly. The Whopper.
Sounds like the starting to horror movie.
Yeah.
I actually spent some time this weekend. I downloaded an app for tic-tac-toe
Mm-hmm.
just to see how what other people, what kind of things other people were doing.
Cool. Anything interesting?
No, I never found a hard mode that was
okay.
hard. It seemed pretty random.
One person in the other section mentioned the idea of having both people be the same mark, right? And technically you could do that. You could both be X, and you can't just use an X in your board, but you could use a flag that says, is this the user or the CPU, and have something else that says, how should that be painted, an X or an O. And then you could have everybody use the same mark, and it would be a memory thing, right? You have to remember which ones were yours. So that would be kind of cool.
The computer would have a huge upper hand on that one.
Yeah. Well, yeah.
Is it not like, oh, where did I place it?
Yeah, exactly. And then someone else suggested an option where you could try to force the computer to lose, and that's a whole different algorithm.
Oh yeah, opposite.
Yeah, like if you want to try to have the user always win instead of the CPU.
I was trying to force a draw, and
Yeah, yeah.
I just have mine picking a random ballot square each time, and it's
Mhm.
difficult.
Yeah. But that's valid. And then somebody else pointed out that X is always supposed to go first, which I never knew. Maybe this is-
Wow, I didn't know
Yeah,
that
that's
either.
true.
Is that true? Yeah. So we're extending the game here. You can
Yeah, I was
be
about to
you can
say.
be either mark and you can go first or second.
I was like, I ain't changing that.
Yeah,
Yeah,
yeah.
I'm like, yeah, I'm not.
You could probably rig it with radio buttons actually.
Although it doesn't matter, my
Like-
code repaints itself every time anyway.
Yeah. So there's going to be a lot of painting going on in this, right? And repaint is presumably smart. If you call repaint and there's really no work to do, it may not actually do all of that re-rendering. I don't know how smart it is. I think this gets into like what's going on at the hardware level. All right, anything else? So let's talk about the midterm, because that's coming up Wednesday. And then we're going to talk about trees. And we're going to talk about balancing trees. Midterm will be Wednesday, and I'll probably start at 12:10 in case people are coming in late. It'll be 15 minutes till 1 o'clock, and then we'll talk more about trees after that. And your brains will be nice and toasted from the midterm, so that'll be a good experience. So I posted a list of topics. This was assuming I had a network connection. Well, this is fun. All right. Well, you can take my word that it's on Canvas, but we'll just go to the source.
This is supposed to be
gotta click on topics, not the actual midterm. There we go. All right, so things to study, possible midterm topics. First thing, I would definitely review your programming assignments. Okay, those are good examples of the kinds of things that we've been doing and the kinds of things you might find yourself doing. PA1 and PA2, don't worry about PA3, don't worry about swing, window builder, paint. Okay, those will not be on the exam. But PA1, where you were making the fractions class, and PA2, which was linked lists on top of linked lists, definitely go over those. Haven't had many ODPs, but whichever ones we've done, right, you can review those. And your first 3 labs, particularly threads on lab 3. Don't worry about the GPIO specific stuff, the input and output from the LEDs and stuff like that. That's not going to be on there. But the threading and using scanner to get input and that kind of stuff, that's all good review.
Are we gonna have to remember the line to import scanner? Or any other like documentation?
I'm not going to ask you about those imports,
Okay.
okay, because none of us remember those usually. All right, so make sure you're comfortable with the idea of a class and an object, right? So class is basically a blueprint for constructing an object. An object is what you get when you follow the blueprint and you make an actual one of these things. Right? It's not a physical thing, but an actual physical version of the class, right? That's an object. You should know how to define a class, and some of the syntax I want you to make sure you can do. Okay, so if you've been using something like Eclipse from the beginning and you have no idea how to define a class, do some practice on it, jot it down on your notes, something. Okay, class, space, name of the class, well, you don't need space. Class, space, name of the class, and then curly bracket, all your definition, closing curly bracket. Okay, you should be able to do that from your notes or from memory.
Same with main.
Say what?
Same with main.
Same with public static void main parentheses string bracket bracket args, or whatever you call the argument list, right? So if you don't know how to do that, put it on your notes, because I want to see that if I ask you for a main method. Fields and methods. Okay, so fields are basically variables. You have a class, and let's just pick on our favorite class. So that's the beginning of a class definition. And here's 2 fields. We call these instance variables, right? So each time you create a rectangle, you're going to have an H and you're going to have a W. And you might have instance method like area. So this takes the height and the width of the rectangle, multiplies and returns that. And so over here, if I say something like rect r equals new rect, and in our examples we had a way to construct a rectangle of particular dimensions, but even if we don't, we construct a rectangle, we can say something like r dot h equals 5, r dot w equals 7, and I would make these public if you can access them. So r is an instance of a rectangle, r dot h is one particular height of that rectangle, right? If I have a new rectangle r2 and I do something with r2 dot h, that's different from r dot h, okay? And I can also say something like integer a equals r dot area. And r is an instance of a rectangle. This is a method inside that class, so it will call the area method. And when this area method runs, the h that it picks up is going to be r dot h. The w will be r dot w. So it gives you the area of that rectangle. So being able to write things like this, being able to use those fields and those methods. All right, and then constructors let you do something more specific when you make a rectangle. So this is just constructing an empty rectangle. There's no initial value for anything. But you can make a constructor, and remember your constructor is going to be something like the name of the class, right, with no return type, and then whatever arguments you want. And maybe we want a default constructor with no arguments. That just sets the height and width to 1. So you should know those mechanics, right, and be able to put them down on a test. Public and private control the scoping, okay? So when you mark something as public, it means things from outside this class have access to these things that are marked public. If these are marked private, only things within this class definition have access to it. For example, I want to use the H and the W in here. If I mark these as private, I can still get to H and W because I'm inside this class where H and W are defined. But if these are marked as private, this won't compile. Okay, if they're marked as public, then this becomes valid. If I had a private method and I tried to access that from outside the class, I'd get an error saying that's not visible. So they control visibility, not scoping. They control what you can see from different contexts.
I was wondering why, if you go back to that paper, you see where you say r.h, why do people use setters as opposed to doing it that way?
Because in some cases, you don't want people to be able to say, for example, r.h equals -5. Because now when I try to convert it to a square, my square root's going to blow up because my area looks negative.
But if you use a setter, then you could
Use
have
a setter, I
or
can
a
check,
setter.
and if your argument's negative, I can say no, no, no. So we like this idea of information hiding and encapsulation. So here's your interface to this data structure, right? And the fact that there is an integer called h that represents the height of the rectangle, that's not part of the abstract data type that we call a rectangle. Rectangle is just a parallelogram? It's more than quadrilateral. That's better, 90 degrees. Rectangle is just a quadrilateral with a height and a width, right? So you can construct it, tell it what the height and the width is, and so on and so forth. This is also saying, you know, it's something with an H and a W. And that's more than what we think of as an abstract rectangle, right? And if I call this, you know, height in centimeters, you'd have to know that a rectangle was something with a height in centimeters field, right? So it's breaking this idea of here's your interface to the rectangle, here's all the stuff going on. So, so we use setters and getters. In some sense, it's why you have a gas pedal. This will be a stupid example. It's why you have a gas pedal on your car instead of just having a hose that you can pour gasoline in, right? Not that you would do that. But it might be fuel injected, it might not be fuel injected, right? It doesn't matter to you. You just press the pedal and it does its thing.
I use setters, but so far the only reason was because it was a shorter line.
Okay. I thought you were going to say you had a hose in your car. And you
Yeah, and I
gasoline.
pour gas in. I thought everyone did it that way.
Yeah, yeah.
How would you regulate your speed? You just overload it?
Yeah, you like suck some out if you put in too much. I'm sure it'd be good. Although old anybody ever have an old Volkswagen? The double gas tank? Apparently there were 2 gas tanks in the back, and when your car started to sputter because one tank was running out, there was a little switch you could flip with your foot, and it would turn on the second gas tank, right? And then you'd get gas from there, and you'd know you had to get gas too, and you'd have to fill up both tanks. It's one of the few things I remember from my PhD in math. All right, so defining methods, writing constructors, public, private. Okay, good. Be prepared to write code, to modify code, to analyze code. Okay, same as you've done in every one of these courses. So I might say write code to create a class with these characteristics. Okay, or I might say write a method inside this class that does such and such a thing, or change this code or add something to this code in order to achieve some effect. Or here's some code, tell me what such and such does. Okay, so just kind of being comfortable with writing and reading Java code. Linked lists. So we've definitely done linked lists, right? And let me mention something here. I didn't really mention this in the comments on PA2, but I might have mentioned it in class. So let's think of a linked list class. Okay, so we'll call it LL. And we got some kind of handle to this thing, something that we use to get a hold of the first node. I'm just going to call it header here. And we might initialize that to null if we don't have a sentinel. And that header is usually of a type node, and class node might look like this. It's got an integer data, and it's got a node next. Now here's what I saw on some PA2s. And there's methods in here for inserting and searching or whatever else. But in some cases, people used a single class for both the list itself and the nodes in the list. And this works, okay? It compiles, it runs, it does the right thing. But logically, it's sort of combining two things that should be thought of differently from each other. This is the linked list. These are the nodes from which the linked list is made, right? These are little boxes. This is a collection of boxes pointing at one another with some sort of handle to the first node. What you're doing when you have this is you're making each node a little linked list in itself that has a header and has some methods for doing insert and delete and so on and so forth. And it's kind of missing the idea that the linked list is comprised of these nodes, right? And we'd like the node to just be this thing that has a piece of data and a pointer to another node. And the list is a collection of those with some code for traversing and searching and so on and so forth, right? You can do this and it will work and it will compile, but it's not clean. And it can get you into trouble when we start doing trees, implementing trees next week, right? This kind of separation is going to be very desirable. So if you did it like this without having a separate class for your word list node and your position list node, right? Think about how you would break those out. Does that make sense? All right, so linked lists. Defining nodes, starting a list. So if you have a sentinel node, your empty list is just a sentinel node that points to null. If you don't have a sentinel, your handle is null to begin with. And when you get a first node, your handle refers to your first node and so on. So some way to get a hold of your list, adding nodes, searching for nodes, deleting nodes, traversing the list starting at the beginning and moving all the way down and so on and so forth. We didn't do all of these in PA2, but you've done all of this in 222, right? So those kinds of list operations applied in Java, you should be okay with doing those. You should definitely know the scanner class. So this is one class I want you to know in particular how to construct it. And the two ways that we've constructed is from system.in, that reads standard in, or by saying scanner parentheses, new file parentheses, and then the name of a file, right, a path.
Use a try catch.
And that's going to need a try catch because if the file doesn't exist, the constructor will fail. And then I want you to know about next line, has next and has next line, and the fact that there are other things like has int, has next double, things like that. But mostly I want you to know has next, has next line, and what those do. Okay, next pulls in the next token, next line pulls up everything through the end of line. And if you know those, you've got everything you need about scanners for the midterm, and probably for most of life. Yeah?
What was the second method with the try-catch?
Oh, so if you're constructing from a file, right, so this says open a file and create a scanner that reads from that. This constructor will fail if the file doesn't exist or isn't accessible. So you'd want to throw that inside a try-catch. And so I say somewhere around here, try-catches are something you should know. So let me just do those here. And this is more syntax that I want you to be able to reproduce. So try curly bracket, body of the try block, catch curly bracket, body of the catch block. So these statements in the try block get attempted. If they all succeed, the catch block is ignored and you come down after that curly bracket. If something goes wrong in here, the system will look for a catch block, and there's something like an argument on this word catch, and it's the name of an exception, and then a variable. Typically it's E. And here's what happens. If you get an exception that is of this particular type, it'll start executing the catch block. An exception with an uppercase E, that's the most general exception. There's also IO exception, and there's all these other exceptions that are extensions of exception. But if you say exception and anything goes wrong up here, it'll match this tag and it'll come down into this block. And before this code starts executing, this variable, E in this case, will be set to an instance of the exception class that corresponds to what went wrong in the try block. So you can use various methods from exception to see what the stack looked like or what the error message is and so on. So you definitely want to be able to write something like that.
Is there a catch-all?
There's a finally block, but we haven't gone over that. But at the end you can put, this is a catch-all basically, right? Any exception will match an exception. And if you have other kinds of exceptions, you could say catch IO exception, catch some other exception, and it'll match the first one that it agrees to. So this is basically a catch-all. And then there's also a finally block you can put on so that whichever one of these blocks was executed, it'll still come down and do the finally block. So, but we haven't gone over that. All right, strings are another class I want you to know certain particulars about. So you should know the length method, character at, 2 uppercase, 2 lowercase, substring, compare to, and equals. Okay, if you know those, you should be fine with strings, right? These classes have bazillions of methods and fields associated with them. And I don't want you to have to bring in the Java documentation to do your exams, so that's a sufficient subset for the string class. And you should understand why dot equals is different from the double equals sign. So what's the difference between those?
Yeah, the equals sign will check if they're the same object.
Yes.
Dot equals check if they're contexts.
Exactly. So S1 equals S2 is only going to be true if S1 and S2 are the same object, right? If they're different strings that have the same characters inside, you get that by saying S1 dot equals parentheses S2, and that'll come back with true. Or S1 dot compare to S2, and that'll come back with 0. All right, you should know the TwoString method. okay, which is basically something that we normally inherit from the object class, but it allows you to take an object and concatenate it to a string, typically with a plus sign. And when you ask it to concatenate an object to a string, the system will try to convert that object to a string first, and it does that by looking for a method called TwoString. And if you don't write one yourself, it uses the default one from object, but you can define your own. It should be public, it should return a string, it should be called exactly TwoString with an uppercase S, and it takes no arguments. If it doesn't match that, it's not the TwoString that we're talking about. And you can put whatever you want in there. It could return a string, it could delete all your files, it could do anything that you want it to, right? It's going to be called whenever you take an object and you try to treat it like a string by concatenating it. So typically we have it return a string that looks like what we want our object to print as. But it's not strictly related to printing, right? It's really just turning your object into a string. You should know about signatures. So signature of a method or constructor is basically the name of the method and the types of arguments that it's expecting. So if you have a method or a constructor called area and it's taking an integer, a character, and a string, that's its signature. If I have another method called area and it's taking an integer, a character, and a double, that's a different method, okay, because the signature is different. And when you call a method, it looks at the name, it looks at the type of arguments, and it tries to find something with that signature. If it does, that's what it's going to call. If it doesn't find something with that signature, it gives you a compile error.
So you can have methods that are named the same thing?
Absolutely.
So that's how the multiple constructors.
That's how multiple constructors work, and that's the classic example. You have more than one constructor.
Mm-hmm.
But you can do that with any method.
Because in C, you get in trouble with it.
Yeah, in C, you'll get a annoying thing when you link. Did you have a question?
Yeah, I was just gonna say.
Okay, cool. All right, so that's the signature. Try catch blocks we talked about. Yes.
Back to the signature thing.
Mm-hmm.
I was always confused when I was looking up other already created classes where it would be like has next, line next, int next, stuff like that, where they're not explicitly named. It'll just be like has next, and then in the documentation it'll have inside a bunch of string double whatever, and that always confused me. So that's just the same class, but they all have different signatures on what they take.
Those are different names of the methods, though, right?
Not like next int, but I can't think of an example off the top of my head. But ones where it'll be like, I'm trying to think of a good one.
Is the signature only the stuff in the parentheses or the whole?
Yeah, is that
It-
just the input?
It's the name and the arguments you're passing to it.
What about public? Not that part?
Not that part. And not the return variable. Right? And not the names of the arguments, just the types of the arguments. And by extension, it's also the number of arguments, because if you have 3 arguments here and 4 arguments here, they don't have the same types because there's only 3 over here. So the 4th one doesn't even exist here.
And do methods have signatures as well then? Or-
That's what we're talking about, our methods.
Okay,
Yeah,
not
methods and
classes.
constructors.
Okay.
Classes do not have signatures, right? This is just for methods and constructors.
It's kind of like what you put in like a header file or a .a file.
Could be kind of like that. Let me. See if I can find this, yes.
I guess in the header file that you still have what it returns.
So here's a method called setDiameter. I can give it a double and a double. Here's another method called setDiameter. I can give it an integer and a double. right? Same name of the method, different signatures. So I can pass this with an int and a double, and it's going to use this code. Or I can pass it with a double and a double, it'll use this code. Right? I might have a version that takes no arguments at all, and that would have a different signature, and it would be a different method. And internally, right, this might call this by doing something with this first argument and changing it into a double, and then calling with that signature.
What does set karma do?
Sets the karma.
Double.
Oh.
It's the interlinking of cause and effect. All right, other questions on that? Let's see. Try-catch blocks we talked about. Arrays. So we haven't really had much chance to play with arrays. Right, so we can do this, and this works fine. But int with a lowercase I, this is one of these 7 built-in primitives, right? It's still an object, but it's different from the integer object, uppercase I. So in general, if we wanted something like an array of rectangles, we need to do the following. Right, rect bracket bracket x says x is going to be an array of rectangles, equals new rect bracket 10 actually says, okay, I want an array of 10 rectangles. And this is basically setting up a storage area that can hold 10 rectangles. So this is x. But each of these rectangles is null to begin with. Which means if I want to do something with x bracket 0, I have to construct that rectangle first. So I'd say x0 equals new rect with whatever arguments you have. And now this is actually a rectangle. So when we have arrays of objects, usually there's this 2-step process. First, we have to construct the array, and then we have to construct the objects inside that array. Okay, and it's different from what we do in C, and it's different from what we do with primitives, which are designed to work like C. So if you have to make an array of J panels or something like that, right, it's this 2-step version.
So can you return an array from a function?
Absolutely. Yep. And you just say it returns a rect bracket bracket. All right, static versus instance methods, we talked about these last week. So back on our rectangle class. These are instance variables. This is an instance method, so we can access it from an instance of this class. But we can define statics, so we could say static integer magic. And now if we want to access magic, we don't use an instance of a rectangle, we just use the class itself, rect.magic equals whatever. And the way to visualize this perhaps is that for every instance of a rectangle there's an H, there's a W, there's an area. But for the entire class of rectangles there's only one integer magic, right? And any time I refer to rect.magic, I'm referring to the same one variable.
So you could have 10 rectangles, and if you set rect.magic on one of them, it would change it for all.
Yeah, because I'm not even talking about a particular instance of a rectangle here, right? It's really just a class variable.
So if you access magic like through instance, is that just bad style?
It's bad style. You get a squiggly yellow line in Eclipse.
Yeah, I guess that was
but it'll work.
Full error, but it worked.
Yeah. And it's because, right, whatever instance you have, it's still just one magic. But it can look confusing, and Eclipse thinks maybe you were trying to do something different. And then the same thing with methods. So if you do public static, I don't know. Factor h comma w, where you want to know the squareness factor of it or something like that. So you could say rect dot factor and pass it your arguments, as opposed to doing it off of an instance of the object. So that's a static method. And statics are basically things where you don't care about a particular version of the object, right? So math.square root, you don't really care about a particular math object. Factor, which is going to take a height and a width and tell you how square that corresponding rectangle would be. It doesn't look at a particular rectangle. I'm just passing it a height and a width and it's giving me back the ratio or something.
What would be the opposite of having like a static method?
Instance method. So that's like area,
Oh, okay.
right? So that's one that you invoke off of an object. And when you say r.area inside here, I just say h. Which h, it's going to be r.h. Which w is going to be r.w.
So like in Pt2, you wouldn't want the add node to be static.
No. And everything we've done other than main has been instance variables, instant methods, instance methods. Statics mostly make sense when you want to write some code, for example, that you're passing information to and getting information back, and it's processing based on those arguments, as opposed to processing on the value of some particular version of your object, right? Or if you have a field, like in the math class, there's a field pi, it's never going to change, right? It doesn't need a particular object. Or if you wanted to know what the golden ratio was for a rectangle, that 1.57 blah blah blah, right? That could be a static field in your rectangle class, because I just want to know what's this magic number, and it's independent of any particular rectangle. So that would be a static. And then the last thing was this and super, right? So this is a way to refer to yourself. Super is a way to refer to the class that you're an extension of. So if you say this dot x or this dot area or something like that, you're deliberately referring to the version of that variable or method that's defined within this class that you're currently in. If you say super dot variable or super dot method, you're saying whatever class I extended, I want to access a field or method within that class. And the only time we really use that so far is with paint. So super.paint gets the paint method for the class that you extended, such as a JPanel. All right, and again, you won't have Swing, Window Builder, Paint, or any of the graphics class information on here. Sound good? Took us 50 minutes to go through it, so hopefully that means you can do it in 50 minutes. All right, so let's take 5 minutes, and then we're going to talk about some trees.